Okay, so in these ones we want to use a trig substitution. And in all of these we assume that there is 0 to pi on 2. So there's a lot of assumptions that are made that we don't go too deeply into, thank goodness. But yeah, we can assume that theta is between 0 and pi on 2. Just makes it easier. We're dealing with positive answers all the time because in that quadrant sine, cos and tan are positive. So we don't have to worry about negatives. All right. So in the first one, let's have a look, and it tells us what to do. So we're going to let x equal tan theta. When we do that, dx equals sec squared theta to theta. All right, so our integral will now be, so the bottom part will be 1 plus x squared, which is now tan squared theta, to the power of 3 on 2. And the top will be dx, is just dx, and dx we know is sec squared theta to theta. All right, now we do know that 1 plus tan squared is sec squared, so really we've got sec squared to the power of 1 at the top and sec squared to the power of 1½ at the bottom. So 1 minus 1½ is hopefully a half. So our minus half at the, or half at the bottom, or minus half at the top, up to you. So what we end up with is just d theta on sec theta. So square root of sec squared is just sec theta. But of course sec theta is just the reciprocal of cos theta. So that's really just cos theta to theta. And we know when we integrate cos theta, we get sine theta plus c. Now, a lot of people make the mistake of stopping there, but remember we're using a substitution. So we need to put it back in terms of x. So what is that in terms of x? Well, one way you can find out is go back to the beginning. So we said x is tan theta. So if so think of x as same as x on 1. So tan theta, their old age, and use Pythagoras to find the hypotenuse. So if we now did sine theta, sum opposite over hypotenuse, we'd get x on the square root of x squared plus 1. Oops, plus c. So that is your answer there. There we go. All right. So let's have a look at B. So in the same way, we'll do B as well. So it tells us to do x equals sine theta. So we do, and dx would then be cos theta to theta. Easy enough. Okay, so our integral becomes, so we've got x squared at the top, so that's sine squared theta now. So x squared dx, so dx is cos theta to theta. All on 4 minus, and we've got, oops, did I write the wrong thing? I did. That should be a 2 sine theta, hence a 2 cos theta to theta. So what I'll do is I'll just put a 2 at the front there. There we go. 2 cos theta to theta is there. So you can see that at the bottom there we're going to have 4 minus, and we're going to square x, which is 4 sine squared theta. We know that that is 4, 1 minus sine squared theta. Square root of 4 is 2, and the square root of 1 minus sine squared is cos squared. Square root of cos squared is just cos. So we know we're going to get that. So let's put that on the bottom. All right, so 2 can come out the front, and I've got cos theta there. All right, so what have I done? What have I done? Square root of 4 is 2, so now I should have a 4 out the front, shouldn't I? Yep. All right, so that stuffed me up here. So the first thing I had to sub in was my x squared, which I put sine squared, but actually, of course, it was 2 sine theta, so it becomes 4 sine squared theta. Sorry about that. So we are okay now. So the coses cancel, the 2's cancel. I'll put the 4 out the front, and we have 4 sine squared theta to theta. Again, we don't like to integrate sine squared as it is, so we use an identity of half 1 minus cos 2 theta. for sine squared theta. So now we have 2 out the front. Let's just integrate straight away. So we have theta, cos goes to sine, but we need the half there. All right, plus c because it's an indefinite integral. So again, we need to put that back in terms of x's. So if I have a little look at what we did do, we made sine theta be x on 2. So some, oh, my triangle's terrible, some old hags. So again, if I take the square root of 4 minus x squared, just using Pythagoras. So if I use that here, I've got 2 lots of a theta, and if I go back to here again, theta is just inverse sine of x on 2. If I put it in terms of x, minus a half sine 2 theta. Now, a half, so sine 2 theta we know is 2 sine theta cos theta. So that half and that 2 are going to cancel. So I just need sine theta times cos theta. So looking at my triangle, sine theta, some old hags is x on 2. Sine theta and cos theta can't always hide. Okay, so that's our 4 minus x squared under the square root on 2. So I've got all that plus c. So if I just go through and put the 2 in there, I've got 2 inverse sine x on 2 minus x square root 4 minus x squared on 2 plus c. All right, so that is A and B. So let's have a look at C. I just clear all this. Okay, so doing it the same way, they tell us what we want to do. Whoops, there we go. Get rid of that. Here we go. All right, so for C, we've got x being 5 cos theta. All right, so if x equals 5 cos theta, then dx is, so cos goes to negative sine. So you have negative 5 sine theta d theta. All right, so let's redo this integral. So the dx part, which is the part I'm going to put on top, is minus 5 sine theta d theta. And then we have x squared. So x squared is 25 cos squared theta. And I might do this bit separately. We've got the square root of 25 minus x squared. So we can easily see that if we factorize by the 25 and then square root it, we have a 5. And we're going to end up with 1 minus cos squared underneath, which is sine squared. And the square root of sine squared is just sine. So under here, we've got 5 sine theta. All right. Now, hopefully you can see that this 5 and that 5 will cancel. So I'm going to put the 25 out the front, so it's negative 1 on 25. The sine theta cancels as well. So now I've just got 1 on cos squared theta to theta. That would be the same as, because of the reciprocal, would be the same as sec squared theta to theta. So all these little tools help. So we know the integral of sec squared is 10. All right, but we want to put it back in terms of x. So let's go back to our beginning. So we have cos theta is x on 5. Can't always hide. So this will be 25 or 5 squared minus x squared underneath the square root. All right, so let's put that in. Oh, that should be a negative there, shouldn't it? So I've got negative 1 on 25, tan theta there, old age, so I've got square root 25 minus x squared over x plus c, and I could just put them together a bit more. 25 minus x squared on 25x plus c. So that would be c. So let's have a look at d. So for d, let's just move over a tiny bit. Okay, so it tells us to use There we go. X equals tan theta. All right, nice. We can use x equals tan theta. If we do that, dx is sec squared theta to theta. There we go. And while I'm at it, why don't I do my right angle triangle? So it says tan theta is x on 1 effectively, so their old age. So the hypotenuse will be the addition of x squared and 1. Okay, so let's have a look at that integral. So the integral now becomes, so if I put the dx on top, I've got sec squared theta to theta. And we've got x squared, so that's just tan squared theta. And then we've got the square root of 1 plus x squared. Now we know that the square root of 1 plus x squared, so 1 plus tan squared is sec squared. So the square root of that will be just sec. All right, so let's just put that in, sec theta. All righty. What cancels here? So one of the sec thetas cancels there. So we have sec theta on tan squared. If I put them all in terms of coses and sines, that means I have sec is 1 on cos. So I have 1 on cos theta, and then I've got tan squared on the bottom. So I've got tan squared on the bottom would be sine squared on the bottom and cos squared on the top. So that's what we've really got. And if you look at that, we can see the cos cancels there. And we're going to have cos theta on top and a sine squared on the bottom. Now, that means if we think, you could do another substitution here, or just think that the derivative of sine theta, which is cos theta, is already there. So it's like, if I did do a substitution, it's like having u to the power of negative 2, where u is sine. So if you want to do a substitution, if you can't see it, then let u equal sine theta and go from there. But here I've got the derivative at the top, so I just pretend I've got, it's like sine theta to the minus 2, and I can add 1 to the power, so that's minus 1. So it'd be 1 sine theta, and divide by that minus 1. So I've got that, plus c. All right, but what does that equal in terms of x? So sine theta is x, so x on square root of x squared plus 1. So the reciprocal will be the square root of x squared plus 1 over x plus c. And that is supposed to be a negative. There we go. All right, so that's ABCD. Good.